when a brake was applied to a car, a car decelerates. It decelerated at 0.5 meters per second square. When a brake was applied, the car decelerated at 0.5 meters per second and came to a stop in 15 seconds. It came to stop. When it came to a stop, 15 seconds, the final velocity will be 0. Determine its initial velocity. Final velocity is 0. Even if you use the first equation, final velocity is 0. So initial velocity is at. Initial velocity will be the acceleration. Even if you use the first equation, this final velocity is 0. Then initial velocity is u times at. A is 0.5, that's acceleration. Time is 15 seconds. It was decelerating. U minus 0.5, that's acceleration. 0.5 times 15. 0.5 times 15, sorry. So u, which is initial velocity, is equal to 0.5 times 15. That's u. Initial velocity was gotten to be 0.5 times 15, which is 7.5 meters per second. 7.5 meters per second, using the first equation. Now, to get the question said determine its initial velocity, which we have determined, of the car, and its accelerating distance. Its decelerating distance. So we can use the second equation to get the decelerating distance. So if we use this, we have that S initial velocity was 7.5 times the time. The time is 15. Then minus, because it was decelerating, half. It was decelerating half times 0.5. Half times 0.5 times 15 squared. Because of time. I'm using the second equation to get the decelerating distance. The decelerating distance, that's what the question said. Decelerating distance. And then I got this to be equal to 56.25 meters. The distance is 56.25 meters. 56.25 meters. Equal to 56.25 meters. That is the decelerating distance. So, saying the question again, the question says let me see the question. The question said, when the brake was applied, a car decelerated at 0.5 meters per second squared and came to a stop 15 seconds later. Determine its initial velocity of the car and its decelerating distance. That is it. We now first of all got the initial velocity, which started from rest. So the velocity now, when it stopped, the velocity becomes 0. So if we use the first equation, when the brake was applied, I want to say the question again. When the brake was applied, a car decelerated at 0.5 meters per second square and came to a stop in 15 seconds. Determine its initial velocity and of the car and its decelerating distance. So when we now get the initial velocity, which we got here, we now apply it to the second equation to get the decelerating distance. And that is that. Thank you very much.